The compression ultrasonography method is a part of the ThrombUS Plus project system and brings together several key innovations from different partners. A completely silent electronic actuator controller for tissue compression from KTU. An ultra-portable ultrasound beamformer from Telemed. A C-shaped semi-rigid wearable with an integrated air bladder from ComfTech, and a low-profile ultrasound transducer for ultrasonic visualization, in this case a linear probe from Vermont, which is integrated into one part of the C-shaped wearable. The other half of the wearable contains an air bladder that performs tissue compression. The application process is straightforward. First, acoustic coupling gel is applied to the ultrasound transducer. The thigh is then elevated for easier application, and the wearable with the transducer is positioned on the medial side of the thigh. In the setup section of the graphical user interface, an ultrasonic visualization is initiated to identify the patterns of the femoral artery and vein. Once positioned correctly, the actuator is secured using Velcro straps. After the position is secured, the system performs the first calibration compression using the electronic actuator controller. Thanks to the innovative piezoelectric air pumps, the process is completely silent. After finalizing the subject-specific settings, threshold values for pressure and strain are configured for long-term monitoring using the monitoring section of the graphical user interface. The total session duration and pause intervals are also set, after which the system automatically performs compressions and records tissue response data for subsequent analysis. Once long-term monitoring is initiated, compressions are performed at set intervals within a defined time period. The view of the graphical user interface shows a fast-forward playback of the automated compression duplex ultrasonography session, where induced pressure points and the resulting tissue responses, quantified using the strain parameter, are displayed in graphs, along with the corresponding series of images stored in files. At the end of the session, the wearable is removed. If the set strain threshold is reached, the measurement result is marked and an alert is activated, indicating a change in tissue response that may reflect an alteration in the femoral vein. An on-demand measurement can also be taken using the skip waiting function, allowing a quick check and visual confirmation of any tissue changes through real-time imaging. This work is part of the Horizon Europe Innovation Action ThrombUS Plus, wearable continuous point-of-care monitoring, risk estimation, and prevention for deep vein thrombosis, co-funded by the European Union. Follow our journey online at thrombus.eu.